Okay, so let's unpack this. We are diving into a source that, well, on the surface, it looks incredibly dry.
It's a technical data sheet.
Exactly. For an industrial sensor, the NTI E-STHSB-N4085IND-50. But we're going to treat this spec sheet almost like a forensic document.
Right. So the mission here is to extract insights about what industrial monitoring really demands.
Yeah, just from the cold, hard facts of the data sheet.
We want to know, what conditions must this piece of hardware tolerate to be considered, truly industrial grade?
And the first thing that tells that story of tolerance is the operating range. This is not for a climate-controlled office.
Oh, not at all.
It's built to handle temperatures from a punishing -40.
All the way up to 185 degrees Fahrenheit. That is a massive operational envelope.
A huge range.
It is. And when you see minus 40 degrees Fahrenheit or Celsius, they meet there. This sensor is meant for unheated places.
Like what? Remote pipelines, maybe?
Remote pipelines, storage containers in extreme climates, that sort of thing. And it also covers the full 0 to 100% non-condensing relative humidity range.
What's fascinating, though, is how the accuracy changes based on that stress. For the temperature range, most people might use, let's say, 14 to 185 F. It's excellent.
It is. It's plus or minus 0.7 degrees Fahrenheit. Very precise.
But they get specific about the cold.
Exactly. They explicitly state that when it gets brutally cold, from -40 up to 14 degrees, the accuracy dips a bit.
To plus or minus 1.6 degrees.
And that's not a flaw. That's transparency. It tells you the physical limits of the measurement component itself. The humidity specs are just as detailed.
So surviving the elements is one thing, but it also have to phone home reliably.
Right. Across noisy factory floors, that's a whole other challenge.
So let's look at the architecture. It's simple to power. It runs on 5 EDC. Pulls a tiny 13 milliamps.
But the communication protocol is what's crucial for reliability. It uses RS-485.
Which is an industrial workhorse, right?
It really is. Unlike, say, standard Ethernet, which can struggle with interference, this digital output signal is specified because it grants, and I'm quoting here, high resistance to external influences on the cable.
So it's designed to just cut through electrical noise from motors or other heavy machinery.
That's the resilience, yeah. And for anyone curious about compliance, it's TAA compliant, CE, and RoHS approved. It meets some very high government and international standards.
Okay, and it's designed to be compatible with NTI's own monitoring units.
Correct, the Envirom UX units. But the physical reach is what truly defines its use case. The standard cable is 50 feet, but they offer custom lengths up to 1,000 feet.
1,000 feet is a huge run for copper.
Yeah.
That's already pushing a limit based on signal degradation.
It is.
So why even bother with that limit when the specs hint at something much, much bigger?
And this is where it gets really interesting. This is the key aha moment.
Okay.
The sensor is compatible with the eFSC fiber converter extender.
So fiber optics.
Fiber optics. It just eliminates the interference and distance problems you get with copper entirely.
So emphasize that scale for us. What does using that fiber extender actually allow the sensor to do?
It means the sensor can be located up to 1.2 miles away.
1.2 miles.
2 kilometers away from the core monitoring unit. That turns environmental monitoring from a simple room-scale issue into a massive site-wide challenge.
So at the end of the day, what does this all mean? We took one data sheet, and we learned that monitoring critical systems needs 3 things.
Right. Precision under stress.
Extreme robustness in its communication.
And the ability to scale its reach across genuinely vast distances.
Using fiber.
Exactly. And as a final thought for you to ponder, considering its $310 price and 2-year warranty, what type of critical infrastructure needs that kind of range?
Right.
Think about monitoring ventilation in a deep 1-mile highway tunnel or ensuring stability across a massive military base. It makes you think about where these seemingly simple sensors are quietly working all around us.